Hello, welcome back to the short lectures in physics. Topic for discussion in this session is atmospheric refraction. We all know that the light travels in straight paths in a homogeneous medium, and when it travels through two or more different media with different refractive index values, then the light ray changes its path from its initial direction through some angle when it passes the second medium. If the ray enters the boundary between the two media at 0 degrees angle of incidence, that is normal incidence, then the ray travels in straight path without any deviation. But if it happen to enter at an inclination with an angle of incidence, that is oblique entry, then depending on the nature of the media, that is refractive index values differences, the deviation from straight path takes place for the beam incident on the boundary. This phenomena is known as refraction of light, bending of light from its straight line path when crossing the boundary between two media with different optical properties. The medium through which light travels can be either denser or rarer. So while traveling from a denser to rarer medium, like air to glass, the ray bends towards the normal, that is perpendicular drawn at the boundary surface at the point of incidence. The ray bends towards the normal, that is close to the normal in the denser medium. If it happened to travel from the denser medium to rarer medium, then the ray moves slightly away from the normal with reference to its incident angle. The same refraction phenomena can also be observed when we see the celestial bodies like stars, planets, sun, moon, etc. This is known as atmospheric refraction. The cause for the atmospheric refraction is temperature and optical density variations in the atmospheric zones around the Earth, which varies with the altitude above the surface. We all know that temperature decreases with the increase in altitude. So the air becomes less dense at higher altitudes as compared to that at the ground surface. That's the refractive index of different layers of Earth's surface, Earth's atmosphere decreases with increase in altitude. Also, convection currents exist when there is a temperature difference within a zone. So the transfer of heat takes place within the zone from cool areas to hot areas. Air molecules also keep moving. This is known as convection. Also, the refractive index of the media changes. Refractive index of medium at atmosphere at upper layers is less, and it increases with decrease in altitude. In other words, atmosphere at higher altitudes is rarer as compared to that at the Earth's surface. This makes the light coming from distant objects like stars, sun, etc., any other celestial body. They keep bending, continuously bend towards the normal as it enters the Earth's atmosphere. When the light from the celestial body enters the atmospheric zones at an angle of incidence, that is oblique incidence. This sort of continuous bending of light as it travels from celestial body through atmospheric zones and towards the Earth is known as atmospheric refraction. Some of the examples we can see in day-to-day life while observing the sky is sunset and sunrise times. Let a person is observing the sunrise by standing at point O. Actually, the sun is at a position S, still it has to come to horizon, that is the sunrise to occur. But the light coming from point S, that is sun position, actual sun position, keeps bending towards the Earth's surface. So, to an observer looking at the sunrise, he feels already sun has come, and as he can see the sun at the position S prime, that is apparent position of the sun at sunrise time. The sunrise, according to observer, already occurred a few minutes before the actual sunrise time. This is due to continuous bending of light coming from sun at the sunrise time. So sunrise can be felt a few minutes before, about 4 minutes. Similarly, the same phenomena occurs at the sunset time also. At the sunset also, even though the sunset uh, happened and the sun has gone to position yes, but still to the observer, he feels sun is at S prime position, and hence he feels sunset yet to occur. So the both sunrise and sunset, there is a some time lag between the two actual incidents. The daytime appears to be longer by about 8 minutes due to this atmospheric refraction phenomena. Also, at the sunrise sunset times, the sun appears to be flat instead of round surface. This is because the rays coming from the top portion of the sun and bottom portion of the sun, they refract in different ways. The light coming from top portion of the sun bends less because of the um, differences in the refractive indices of those zones that come across the light traveling through from the top surface of the sun. At the same time, the light coming from the bottom part of the sun bends more because of those conditions. Hence, the sun appears to be flat like S prime as shown in the slide instead of round shape as shown uh, in the slide as S. So the atmospheric refraction also affects the shape of the sun to an observer. Instead of round, it appears as flat. One more example is the light coming from stars. Generally, stars are far away from Earth uh, as compared to other planets, known planets. So they appear dull in brightness. Light coming from star also undergoes multiple refractions while traversing through layers in atmosphere with different optical densities. Hence, it bends at layers present close to the Earth. It bends more at layers present to close to the Earth. So the star appears to be at a slightly higher position, at a higher altitude than its actual position. Even with for other celestial bodies also, they also appear to be slightly at higher altitudes than their actual positions. Here one more thing you can observe is, we mentioned that there are convectional currents uh, taking place because of the temperature variations within the zones. So the air molecules in the medium keep moving up and down. Thus, the apparent position of the star changes to between positions 1, 2, and 3, as indicated by blue, red, and purple colors lines to indicate the refraction occurring depending on the convectional effects also. As a result, the brightness of the star changes frequently because the distance is changing and other effects. The brightness of the star changes frequently, so they appear twinkling. So this is the reason for stars uh, to appear at higher altitudes and keep twinkling. Means brightness decreases, increases with frequently. This is the reason. Of course, this cannot be seen with planets because they are very close to Earth than stars and more brighter. So the twinkling effect is not seen in case of planets. Hope this gives a better understanding about atmospheric refraction and the phenomena what we observe in the sky daily. There are many more examples, but we'll we conclude here. See you in the next session. Till then, bye.